Now we're interested in connecting the curl and a function to be conservative. Theorem. So this theorem says if F is a vector field in the space, if F is a vector field in the space, whose components have continuous partial derivatives and the curl of F is equal to 0, then for sure you can conclude that F is conservative vector field. Then F is a conservative vector field. It means that we can find the potential function, conservative vector field. We can find the potential function F such that our vector field is equal to the gradient of that potential function. So this is the theorem given to you. The contrapositive of this theorem is, let's write a note. If function vector field is not conservative, then the curl is not 0. So if vector field F is not conservative, then we can conclude that the curl of your vector field is non-zero. So it gives us a nice criteria to check to see if a vector field is conservative or not. A quick example for you. Is vector field F, which is defined as y squared z cubed 2xy z cubed, and the last component 3xy squared z squared, conservative? Okay, very good. We know that if curl is equal to 0, then we have a conservative vector field. So if we can show that the curl is 0, then we're done. If we can show that curl of F is 0, then we are done. So what is curl of F? Curl of F, as you remember, let's just plug everything into the formula I, J, K, partial derivative with respect to x, with respect to y, with respect to z. The first component, y squared z cubed, 2xy z cubed, and 3xy squared z squared. This guy is I. So we are taking the partial derivative with respect to y, which is 6xy z squared, minus taking partial derivative with respect to z, 6xy z squared. So far you have a 0 minus j. So here partial derivative with respect to x, 3y squared z squared minus and partial derivative with respect to z, 3y squared z squared, again 0 plus k, and the last component, partial derivative with respect to x is 2yz cubed, partial derivative with respect to y, 2yz cubed, again, this guy is also 0. So we end up with 0, 0, 0, or 0 vector. So since the curve is equal to 0, we have a conservative vector field. The answer is yes.